Alright then, so we're going to solve this differential equation. Now this might look a bit nasty, but actually, you can trust me, it is very easy. Now we're going to minus 4 dy by dx. Let's go. And then add 12y minus 2y. No, or minus 12y away. And we'll put that equal to 0. We're going to solve this differential equation. Now, as you were before, you probably split this up a little bit, right? So you split it when you are factoring a quadratic, you split it and you factorise each two terms. Alright then, let's go a different colour, shall we? Let's crack on with this. So what our factor is going to be? What multiplies to minus 12 that adds to minus 4, or minus 6 and plus 2 would do that. And our minus 12y, and we got our d2y by dx squared. So we've got to this part of our differential equation. What we can factor out is d on dx, not dy by dx. We can bring that factor out of dy by dx minus 6 of y. When you differentiate that, you'll get back above. And then I can factor a 2 out of this one only. So I've got dy by dx minus 6y equal to 0. So we're at this point now where I can let a substitution come in place. Let's let u. To be honest, there's no real... it doesn't really matter what you pick. So we can rearrange, get a bit of solving, so we get du by dx. Make sure it looks like a u and not a y. If anything, that's something to go by. Should be equal to 0 now, so that's just differentiating du by dx. And then we're going to need an integrating factor now. So our integrating factor is, we know we do e to the power of integral of p dx. Pretty simple, right? So it's going to be e to the integral of what? We've got a second order differential equation. What's in front of the p of x? Well, it's going to be the 2. So we've got the integral of 2 dx, which is e to the 2x. So we're going to multiply through the differential equation by e to the 2x. So we'll get e to the 2x du by dx. And then we're going to add 2e to the 2x multiplied by u into it, yeah. That should be equal to 0. I have to rack through my brain in order to do it. Well, this is a reverse product rule of e to the 2x times by u, or u e to the 2x, whichever you prefer. And that is now equal to 0. You can integrate both sides, and you'd end up with actually with u being equal to c1 e to the minus 2x. The reason why that is, if you watch the previous video, you'll know that when you do the reverse product rule, you end up with the integral of this side on the right hand side. So what we're going to solve now with this differential equation, with these recurring mechanics and all this kind of stuff, differential equations is quite useful. Anyway, we've now got this differential equation that we can actually solve, and we can substitute back in. So we can get dy by dx minus 6y, be careful where we substitute in, it's going to be c1 e to the 2x, right? Now it's the dimension. You know when these go wrong, you know it doesn't work. Then we'll call that one I2. This one over here I'll call I1 as well. Just for completeness, because you might get your eyes mixed up. It does happen. It's going to be e to the power of the minus 6x. Well, the integrating factor is going to be e to the minus 6x, and it's equal to e to the power of the integral of minus 6 in respect to those, which is minus 6x, isn't it? So we'll multiply through the differential equation by e to the minus 6x. Minus 6 times y, or 6 e to the minus 6x multiplied by y, and then we're going to put that equal to this right hand side, which was c1 e to the minus 2x. So when I multiply through, we're going to be careful, so I'm going to get c1 e to the minus 8x using your indices laws. Up to you. C2? Well, it will still be equal to the C1 e to the minus 8x that you get from doing the integration down earlier on. Question. So we've now got this now. Now, when you integrate both sides, you're going to get e to the minus 6xy, because you're integrating the derivative, you'll get back to itself. It's going to be, well, the minus c1 over 8, because if you don't know how to integrate e, you need to go back and watch that video. E to the minus 8x, and then go add some other constant now, which I'm going to call c2. It doesn't really matter what you call it, to be honest. Now we can form and get y equals out. So we can get minus c1 over 8, it'd be e to the minus 2x, we'll see if you do that right, if you divide through by that. And then you would add, now I know what the answer should be, but I've done these so many times, c2 e to the 6x. And then you might see it with constants a and b out the front, doesn't really matter. A e to the minus 2x plus b e to the 6x. Depends what exam board you're on. That's the end of the question, by the way. It depends what exam board you're on. So on AQA, they're quite specific and they want you to use C1 and C2. On Excel, it doesn't matter. You can put A and B. Totally fine. No issues with that at all. So check your exam board, but that is the way that I would solve this differential equation. Alright, so in the next video we're going to look at what's called the auxiliary equation. The easy method, and make this a little bit easier for ourselves instead of this long-winded method.